Hey everybody, I wanted to give you kind of a basic overview about angles and directions. If you just draw out like a plus sign, then between your verticals and your horizontals, they're multiples of 90 degrees. So if I were facing straight up and I turned to the right 90 degrees, then I'd be facing straight to the right. If I turn to the right 90 more degrees, I'd be facing straight down. If I turn to the right 90 more, I'm going to be facing straight to the left. If I turn 90 more, I'm going to be facing straight up. If I want a diagonal, my pure diagonals, the ones that divide each of these sort of in half, that's 45 degrees. So if I'm facing straight up and I turn 45 degrees, I wind up on that diagonal that way. So if I do less than 45, I'm going to be somewhere up in here. If I do somewhere between 45 and 90, it's going to be somewhere in there. This is just talking about if I'm starting straight up. So if I think about 0 being the way that I'm facing currently, then I have 45 going this way, 90 be this direction, plus 45, 180. If you guys know much about like completely straight angles, if you have a line here, then that makes 180. Yep. 45 more is, I want to say 225. Yep. 225 degrees. This is 270. This is 315. And that'd be, if I turn all the way around, that'd be 360. And that's if I just start by turning off to the right. Obviously, if I want to go like in this direction, I probably wouldn't want to turn right 315 degrees. That takes a long time. It takes, if you've got a real robot, it takes battery power. I want to say, instead of going right, I want to say, what about if I just turn left by 45 degrees? So if I turn left, let's go, I guess maybe this way. If I turn left, that's 45 degrees to the left. If I want to go this way, instead of going 270 to the right, I can go 90 to the left. If I want to go 135 to the left, instead of 225 all the way around, and then 180, it doesn't really matter at 180. So think about the direction you're going and what would be the easiest way to get there. If I were starting off with my robot pointing to the right, I can just turn this whole diagram this way. And now let's say I want to go up, I might turn left by 90 and that would put me straight up again. And I'd be facing this way. If I wanted to go to diagonal pointing downward to the right, I want to turn right 135 degrees. Then when I get to the end of my path, that's kind of how I would get to where I need to go next. Let's say I want to go straight up again. I go left 135, and that'd point me straight up again. The thing with an angle, like if I have an angle drawn, let me look at the paper instead of my phone. That's a 90-degree angle approximately. That's about a 45. That's about a 30. If I go a little farther, that's about 140 something-ish. And that's just because I'm comparing the two sides. If I were to draw something like an N, where I go up and down and up again, like if I'm driving in this direction along, up here, I'm not going to turn 30 degrees. I mean, the small part here is 30. But since I would be facing this direction, I have to turn all the way to that way. So that's closer to 135 or more. Because it's talking about the direction you're facing to the new direction you're going to go. Okay? So it's a little bit complicated in that even if you kind of know like the size of angles from looking at them, this is about a 90, that's about a 45, that was about a 30, this is about 140 or so. If I see this angle, that's a small angle. If I want it to be a 30-degree angle, well, the whole straight line is 180 degrees, right? The whole thing. And if I want to say this is a 30 degrees in here, so if I do 180, I subtract 30, I get 150 degrees. That's how far I turn to go from this part down to here. So you can think of it like I've got, what is it, complementary or supplementary angles? I should know these things. I have two angles that add up. If this is a straight line, my drawing is terrible. That's 180 degrees. This piece here plus this piece here, the two of them add up to 180. So if I'm thinking I'm going to go, I want to make this shape right here. I want to go from here going straight up, and I want to go slightly to the right up there. That is an angle that looks kind of big, like a 150 or so, but look how far I've turned. I've only turned, from my original direction, I've only turned about 30-something degrees. Okay? Let's look real quick at some sort of questions. If I have a robot path where I start facing straight up and I drive forward, and then I make a turn and I drive this way and I have an end point, so I go right 120 degrees about? Right 60, left 120, or left 60? Well, think about the direction you started in. I'm going to use a paper clip because I can sort of see through it and it's kind of small. If I'm facing this way and I want to turn to face that way, if I hadn't changed, I'd be going straight up. I need to turn to the right a little bit, but not fully 90. 90 would put me straight to the right. I'd turn less than 90 to the right. Oh, so right 60 degrees. That's it. What if I wanted to turn left 135 degrees? What would that path look like? Well, first of all, I'm going to be comparing it to where I would have been going if I'd kept going straight. And I'm going to go to the left, so it's going this way. 90 degrees is over here. 180 would be straight down, so it's in between the two. And really, if I was going to think 180 minus 135, what I'm left with, that's 45 degrees. So if I were to divide this up here, I'd have a 45-degree angle down here. 135 will be kind of in this direction, so I go all the way that way, and I'd be facing that direction again, and I can drive that way. Match your angle measurements. I have this guy right here. This guy here, if I just look at the interior angle, that's a 90-degree angle. This guy is small. This guy's also smaller than 90. These are both smaller than 90, so those are going to be 30 and 60. This guy's smaller as angles go, so there it is. 60. And look, there's only one that's more than 90. That was a bad arrow. And that's that one right there. So the more comfortable you get with these, the better. If you want to, as you're going through, let me see if I got Vex up still. Yeah. If you're going through, you can, I just made this, I was going to do it online, but it's easier to draw it by hand than to try to have a little robot do all the drawings for me. But if you wanted to, you can always make like a little tiny program where I tell it to drive forward, then turn for a certain degree, then drive forward again. And I can say, okay, let's try it. Let's try 30 degrees and see what that does. And play it. And 30 degrees turns you a little bit away from straight up, and it makes that shape like that number right into the wall. Let's see, about something like, I don't know, 50 degrees. That's really close to 45, so it should be really close to a perfect diagonal when it goes right. What if I want it to turn left? That much. So you can always play with these angles here and try to figure out stuff like this. You can always write a quick little Vex code like that and see what your robot does. Alrighty? That's it. Y'all have a good one. Bye-bye.